interface client, and it is used to interact with Ethereum networks. Create a private Ethereum blockchain network. For development purposes, you can set up a private Ethereum blockchain that is separate from the main Ethereum blockchain. A private network is useful for testing out distributed applications without needing to use real Ether. Here, we assume that you are on an Unix computer. Create an Ethereum directory where you will store your local blockchain. So that is mkdir make directory Ethereum. Create an environment variable called Ethereum home in your .bash profile file in your home directory. Ethereum home should point to the directory where you are storing your Ethereum DApp folders. So the command may be echo export Ethereum home equal to /path to folder Ethereum /.bash profile. In your Ethereum directory, create a new file by the name genesis.json JavaScript notation. Paste the below code and save. A Genesis block is required for a private network. This defines the properties of your blockchain. The difficulty property determines how long it will take for miners to mine the block. We recommend setting it to something low. So you have config chain ID, homestead block, EIP 155 block 0, 158 block 0, difficulty set to no level, that is just 2, gas limit brace, and allocation brace. Initialize a new blockchain network with the Genesis block and create the first node. Again, create a directory in your Ethereum home path for your first node. For example, chain1. In a console window, type the following. Get $dir $Ethereum home chain init Ethereum home genesis.json. Then start your node. Note that each node runs on its own port. So if you run multiple nodes on a development machine, they each need a unique port. Also, you need to include the network ID flag if you want to pair the nodes. So get data dir $Ethereum home chain1 IPC disable port 30301 network ID 15 console to console.log. If everything went well, you should now be in the getEdge shell with a chevron prompt. Accounts are a fundamental concept in Ethereum. Create a new account so you can mine blocks, send, receive Ether, etc. So personal.new account bracket. To know which accounts already exist, you can always type personal.list accounts. Step number 8, now create a second node on the same network. Create a second directory in your Ethereum home path. Then open a new console window and enter the following to initialize the node. So it is getEdge data dir $Ethereum home chain2 init Ethereum home genesis.json. Start your second node. The second node must have the same network ID as the first node for the nodes to be able to communicate. Also note that the port for the second node needs to be different than the first node. Here 30301 for node 1 and 30302 for node 2. So it is getEdge data dir $Ethereum home chain2 IPC disable port 30302 network ID 15 console to console.log. Now connect the nodes. In the second node instance, type admin.nodeinfo and copy the enode URL from the console output. Then in the first node, run the following. Admin.add peer enode URL from above. Start mining blocks. Blocks will be empty at first. Miner.start bracket. Stop mining in both the consoles. Miner.stop bracket. Check that the number of blocks is the same in both consoles. ETH.block number. If the nodes
excuse
are...
me, sir, can you
Hello?
please go to the previous slide? Hello, excuse me, sir.
Last slide.
Previous slide.
Okay. Number 7, number 8, number 9.
Yeah, previous steps. Yeah.
Still,
No. Yeah, not this one. Previous. Previous to this.
4, 5, 6.
Yes.
Okay. So you have 2 nodes as such.
Okay, sir. Got it.
Okay.
Got it, sir.
So one by one,
continue.
you have to start them. One by one, you have to start them. The port numbers are 30301 and 30302. Those are the port numbers.
Sir,
Okay.
Yeah.
you wrote that you need to include the network ID flag if you want to pair the nodes. What does it mean? If you want to connect these 2 nodes in the same network, you need a network ID flag.
Correct.
So what that number indicates? 15. We can write any number we want.
You can write any number.
Okay. And sir, in Genesis block that we have created, what are the properties written over there? There were some variables, fields written.
Yeah,
Can you
there are
please
some
explain
variables
the
like config, chain ID, homestead block, that's 0, EIP 155 block 0. Now copy paste kar lo ye sab. This is something which is very common as properties.
So,
इनको
sir,
आप copy paste कर सकते हो.
what this chain ID is for what we need to, what is the meaning of this chain ID?
Basically what is going to happen are transactions as such are going to happen, and when you say chain ID 1 2 3 4, so the sequence in which these particular transactions need to be taken and the chain need to be made, it has to be 1 2 3 and then 4. That is the chain ID.
Okay.
That is the chain ID.
Sir, what other value we can put here?
You can always say
A, B, C,
you
D?
can always say 2468. You can always say 1357.
So it is merely a number.
Yeah, it's barely a number, chain ID. So whatever chain ID you want to provide, you can provide it. Normally it is 1 2 3 4, so that no confusion exists. क्योंकि नहीं तो क्या है, बीच में एक नंबर मिस होगा.
Okay, and sir, as you described in your PPT previous slides, what is guess limit and what is difficulty? Can you please explain what is homestead block? Why it is needed to mention?
See, basically homestead block says that you have to start the block from 0, the 0 address. So that is the starting point. It is the homestead block, and that is given the address called 0.
Okay.
चला. अब ये जो डिफिकल्टी लेवल है कि माइनिंग करने की डिफिकल्टी कितनी है, सो या तो ये समय के हिसाब से आप मेजर कर सकते हो. सो व्हेन आई से 2, इट मींस से फॉर एग्जांपल 2 सेकंड्स, और से फॉर एग्जांपल इट मींस 2 मिनट्स, राइट. सो दैट इज द डिफिकल्टी लेवल. एंड द गैस लिमिट, कितना ये गैस यूज करने वाला है, राइट. सो दैट इज दिस वंस अगेन इज अ हेक्साडेसिमल नंबर 0x800000. So that is the particular gas limit, that this much particular power as such is going to be used in the creation of this particular block.
Okay, sir.
Okay, let's go ahead. So,
okay,
so the step number 10 was connecting the nodes. In the second node instance type admin.nodeinfo and copy the enode URL from the console output. Then in the first node, run the following: admin.add enode URL from above. Start mining the blocks. Blocks are going to be empty first. So miner.start bracket is the command. Stop mining in both the consoles, miner.stop bracket. Check that the number of blocks is the same in both the consoles, that is eth.block number. If the nodes are correctly paired, they should show the same number of blocks, 22, 44, 88, right? So if the nodes are correctly paired, they should show the same transactions or the same number of transactions or the same number of blocks in both the nodes.
Sir,
Yeah.
once we mine the block, it has to be get confirmation from two-third users or
अभी
two-third.
अभी यहाँ पर क्या है, यहाँ पर सिर्फ दो नोड्स हैं, यहाँ पर सिर्फ दो नोड्स हैं, मतलब ये पूरी तरह से इथेरियम ब्लॉकचेन नहीं है, ये आपने एक प्राइवेट इथेरियम ब्लॉकचेन बनाई है जिसमें यू हैव क्रिएटेड टू नोड्स ओनली.
So there is no need of getting confirmation in such kind of experimental
in
environment.
in such a type of experiment, there is no need for confirmation. The confirmation that you are doing is that in both the nodes, the same number of blocks must be present. मतलब नोड 1 में अगर 4 ब्लॉक हैं तो आपके नोड 2 में भी 4 ब्लॉक होने चाहिए, ये आपका confirmation. So it means that both the nodes are containing the same number of blocks. राइट. सो सेम नंबर ऑफ ट्रांजैक्शंस. अगर एक में एक ट्रांजैक्शन दिख रहा है और दूसरे में नहीं दिख रहा है तो दैट इज अ प्रॉब्लम, राइट. सो पेयरिंग इज द कंफर्मेशन. इफ द नोड्स आर करेक्टली पेयर्ड दे शुड शो द सेम नंबर ऑफ ब्लॉक्स. दैट इज द कंफर्मेशन.
Okay. And sir,
यू आर नॉट ऑन द एग्जैक्ट इथेरियम ब्लॉकचेन. सो वो कंसेंसस और उस तरह का कंफर्मेशन की यहाँ पर जरूरत नहीं है.
And sir, somewhere you wrote something like Chevron or what? I don't remember it.
Yeah. So
What
Chevron is the prompt. ये जैसे अपने DOS prompt में दिखता है greater than symbol, वो Chevron है. Chevron is the prompt. GTH का.
Okay, fine. Okay, sir.
GTH का prompt है वो. Right. So
Okay.
it is greater than symbol.
जी sir. जी.
Okay, so the next step will be create a smart contract. So first you will need to install the Solidity integrated development environment, which runs in a browser. I will show you a screenshot of it in the further slides also, which runs in a browser to write and compile Ethereum contracts. So you can go to https://github.com Ethereum browser Solidity tree page. Download the zip file, open index.html to run a local copy of Solidity. Create your first smart contract. Click the plus icon in the top left corner of the Solidity IDE to create an empty file. Double click the new file tab titled untitled.sol. So SOL is the file extension given to Solidity programs, and rename it greeter.sol. Paste the following simple smart contract code into the text editor. So the first instruction here is pragma Solidity, the version of Solidity, that is 0.4.0. Then the keyword contract name is greeter, brace string greeting, function greeter string underscore greeting public brace greeting equal to underscore greeting. Then function greet bracket constant return string return greeting. Then function set string if you want to make modifications, get and set. So string underscore greeting public greeting equal to underscore greeting. Now deploy an instance of the contract to a node in your local blockchain. Stop your first node by typing exit at the chevron and restart it with the correct RPC, that is remote procedure call flags. So it is getH data dir equal to $Ethereum home chain 1 IPC disable port 30301 RPC port 8545 RPC RPC course domain network ID 15 console2 console.log. At the GetEdge chevron prompt, unlock your account with the following: personal.unlock account eth.accounts bracket. Now deploy the contract. Go back to the Solidity ID in your browser, and under the contract tab, change the environment selector to Web3 provider. A prompt will ask you for the Web3 provider endpoint. You have to type HTTPS. Pardon? Pardon?
No, sir, nothing.
You have to type http://localhost, that is 8545. Note that this matches the GetEdge parameter RPC port 8545 that you have written in your command from above. Now, deploy the simple smart contract.
Sir, can you please unmute your mic? Jory, sir. Hello. Jory, sir, can you please unmute your mic?
Yeah, I have done it. I have done it.
Okay, okay, sir.
I have done it. Can you hear now?
Yes, sir.
Okay, okay. So now deploy the simple smart contract. This will deploy the contract to the blockchain in the form of a transaction. In Solidity ID, under the contract tab, find the create button that is attached to a text field. In that text field, type a greeting message like say hi Jay and click the create button. This will call the constructor in the smart contract greeter code with the parameter hi Jay. You should see a message in the Solidity ID that the transaction is waiting to be mined. Go back to your consoles and start the mining process in both of your nodes. So that is miner.start bracket. Return to Solidity and wait until you see the message change from transaction is waiting to be mined to a record of the transaction. You have now deployed the smart contract. The deployed contract has an address, location on blockchain, and an interface which allows you to interact with it. You can now stop mining, go to the GetEdge CLI and type miner.stop bracket. So a smart contract is a computer protocol, rules and regulations intended to
Sir.
digitally, yeah,
So can you go back to previous slides?
sure.
One more.
और भी पीछे,
Yes, one more. The previous to this.
okay.
Okay, sir, here we are writing the contract. So in this contract, basically, just a getter and setter method is there.
Very good. बराबर है, सही बात है.
Okay, then in the next page, next slide, sorry, you wrote that first we need to deploy this contract over both the nodes.
बराबर, सही बात है.
So, sir, you wrote that first we need to disconnect with the first node and then we should deploy it using
Port
RPC.
number 8545. Yeah, RPC port 8545.
So, sir, okay, how this thing will happen in real Ethereum network? Who will
So
deploy?
नहीं, ये real environment ही है. Actually, what happened was ये जो दो आपके कंसोल खुले हुए हैं, उनका पोर्ट नंबर है 30301 and 30302. दो नंबर है, right? So जब अपन ऐसा कह रहे हैं कि now deploy an instance of the contract to a node in your local blockchain, Stop your first node by typing exit at the chevron and restart it with the correct RPC, that is the remote procedure call flag. So here I am assigning the RPC port 8545 to them, both of them as such.
Okay. And sir,
By
what is
typing http://localhost:8545.
and sir, what is this unlocking the account? I didn't get that.
बेसिकली आप एक पर्टिकुलर अपना अकाउंट यूज कर रहे थे जिसका नाम था पर्सनल, जिसका नाम था पर्सनल। इसका नाम था पर्सनल, बराबर ना?
That
So
is
ये
my
जो
GetEdge account.
हाँ गेटेच अकाउंट, करेक्ट, गेटेच अकाउंट। सो ये जो पर्टिकुलर ट्रांजैक्शंस होंगे तो वो इस अकाउंट में होंगे। तो आपने जब कहा GETH शेवरॉन प्रॉम्प्ट पर अनलॉक योर अकाउंट personal.unlock account eth.account 0, so you are trying to unlock that particular account so that the transactions between these two things is possible. इस तरह से पॉसिबल करने के लिए आपने उसको अनलॉक किया।
Okay.
Got it? Or still I need to explain?
No, sir. It would be better if you can explain this steps in more descriptive manner. This 4, 5, 6, 7, 8. That what are the steps actually needed? That first you
Okay.
need to set this and then this,
Okay.
without getting
So,
into this commands.
ठीक है, चलिए। So step number 3 is clear because the ports had different numbers 30301 and 30302. अपन ने एक RPC पोर्ट लिया है 8545। फिर जब आप कहते हैं personal.unlock account, so you have a particular type of a account, right? अपन ने लास्ट सेशन में अकाउंट एंड वॉलेट दो प्रकार के कॉन्सेप्ट्स अपन ने डिस्कस किए थे। सो ये जो पर्टिकुलर आपका अकाउंट है उसमें आपको ये ट्रांजैक्शंस एनेबल करने हैं। सो आप उसको अनलॉक कर रहे हो so that the particular type of ether as such can be sent to that particular account in case you are able to successfully mine your node. Then step number 5 में कहता है now deploy the contract. You have to deploy the contract. So what to do for that? Go back to the Solidity ID in your browser and under the contract tab, change the environment selector to Web3 provider. A prompt will ask you for the Web3 provider endpoint and that endpoint as such जो आपने RPC पोर्ट 8545 लिया है वही आपको enable करना है यहाँ पर। So that is type http://localhost:8545. Note that this matches the getEdge parameter, that is RPC port 8545 from above. Then in the next step, that is the step number 6, you have to deploy the simple smart contract. So ये जो अपन ने कोड लिखा था स्मार्ट कॉन्ट्रैक्ट वाला, राइट? सो उसमें एक ग्रीटर कोड था, ग्रीटिंग कोड था। So under the contract tab, find the create button that is attached to a text field. In that text field, type a greeting message like hi J or hello world or whatever you want to type and click the create button. This will call the constructor in the smart contract greeter code with the parameter hi J. So you should see a message in the Solidity ID that a transaction is waiting to be mined. Now go back to your consoles and start the mining process in both of your nodes by saying miner.start bracket. Then return to Solidity and wait until you see the message change from transaction is waiting to be mined to a record of the transaction. You have now deployed the smart contract. The deployed contract has an address, that is a location on the blockchain, and an interface which allows you to interact with it. You can now stop mining. Go to the GitHub CLI and type miner.stop. Am I okay now?
Okay, so sir, it is like when you so who whatever nodes are available in network, they have to agree on a specific smart contract.
Yes, yes,
And
yes.
how they confirm their agreement is by mining that contract transaction.
Very correct. Very correct.
So in real Ethereum network, when there are multiple nodes or large number of nodes available, if we get majority of confirmation,
Very correct.
majority of miners when complete their mining of this block, that means network is agreeing on this smart contract.
मेजोरिटी हो सकता है, प्रूफ ऑफ वर्क अगर आप बताओ तो वो भी हो सकता है, प्रूफ ऑफ स्टेक बताओ तो भी हो सकता है. सो देर आर डिफरेंट मेथड्स. एक
So it
और
depends on
एग्जांपल मैं
which
लूंगा आगे स्मार्ट
network.
कॉन्ट्रैक्ट का. आई थिंक दैट विल क्लियर योर पॉइंट. सो इट इज नॉट ऑलवेज मेजोरिटी, राइट? सो मेनी अ टाइम्स व्हाट हैपेंस इज दैट पर्टिकुलरली आपने माइनिंग के एफर्ट किए और आपका जो प्रूफ ऑफ वर्क है, if that is taken into consideration by a majority of the nodes, and you have successfully particularly done that particular mining effort, then that can be done. You are correct in your approach, but there can
Okay.
be many methods other than that also.
Okay. And sir, one more thing. Sir, for mining any particular transaction, a particular node must be having its private key and public key signature as well. So we have not created all of this, right? And still
ये
we are
ये ये
writing.
ये क्या था? ये सिर्फ एक ही फंक्शन के ऊपर काम कर रहा था स्मार्ट कॉन्ट्रैक्ट, दैट वाज ग्रीटर ब्रैकेट फंक्शन. इसमें अपन ने कुछ नहीं किया. अभी आगे की जो एग्जांपल है उसमें अपन करेंगे. दैट विल डू इट.
Okay, sir. Okay, sir.
हाँ,
Okay.
मैं करता हूँ. अभी एक एग्जांपल और है आगे.
जी, sir. Okay. Thank you.
So a smart contract is a computer protocol, rules and regulations intended to digitally facilitate, verify, or enforce the negotiation or performance of a contract. Smart contracts allow the performance of credible transactions without third parties. These transactions are trackable and irreversible. The concept of smart contracts was first proposed by Nick Szabo in 1994. Szabo is a legal scholar and cryptographer known for laying the groundwork for digital currency. Smart contract is a set of promises specified in digital form, including protocols within which the parties perform on the other promises. Smart contract is a phrase used to describe computer code that can facilitate the exchange of money, content, property, shares, or anything of value. When running on the blockchain, a smart contract becomes like a self-operating computer program that automatically executes when specific conditions are met. As smart contracts run on the blockchain, they run exactly as they are programmed without any possibility of censorship, downtime, fraud, or third-party interference. So an option contract uses the between the parties is understand the return as a code into market, while the blockchain, the privacy of individuals involved positions are anonymous, but the context is the public ledger. A triggering event like an expiration date and strike price is hit, and the contract executes itself according to the encoded terms. Regulators can use the blockchain to understand the activity in maintaining the individual actors. So points to note पे कहता है, smart contracts are typically written in a high-level language such as Solidity. In order to run, they must be compiled to the low-level bytecode that runs in the Ethereum virtual machine. They are deployed on the Ethereum platform using a special contract creation transaction. This transaction is identified as such by being sent to the special contract creation address, namely 0x0, Each contract is identified by an Ethereum address, which is derived from the contract creation transaction as a function of the originating account and nonce. Nonce is a measure. The Ethereum address of a contract can be used in a transaction as the recipient, sending funds to the contract, or calling one of the contract's functions. Contracts only run if they are called by a transaction. All smart contracts in Ethereum are executed ultimately because of a transaction initiated from an EOA. A contract can call another contract that can call another contract and so on, but the first contract in such a chain of execution will always have been called by a transaction from an EOA. Contracts never run on their own or in the background. Contracts effectively lie dormant until a transaction triggers execution, either directly or indirectly as part of a chain of contract calls. Smart contracts are not executed in parallel in any sense. The Ethereum world computer can be considered to be a single threaded machine. Then the rules for performing the transactions. The transaction rules specify that a contract's code cannot be changed. A contract can be deleted, removing the code and its internal state, that is storage, from its address, leaving a blank account. Any transaction sent to that account address after the contract has been deleted do not result in any code execution because there is no longer any code there to execute. To delete a contract, you execute an EVM OP code called self-destruct. Previously, it was called suicide. That operation costs negative gas, a gas refund, thereby incentivizing the release of network client resources from the deletion of stored state. Deleting a contract in this way does not remove the transaction history past of the contract, since the blockchain itself is immutable. It is also important to note that the self-destruct capability will only be available if the contract author programmed the smart contract to have that functionality. If the contract's code does not have a self-destruct OP code or it is inaccessible, the smart contract cannot be deleted. Transactions are atomic, regardless of how many contracts they call or what those contracts do when called. They are atomic in nature. Transactions execute in their entirety with any changes in the global state of the contracts or accounts, etc., recorded only if all execution terminates successfully. Successful termination means that the program executed without an error and reached the end of the execution. If execution fails due to an error, all of its effects, changes in state, are rolled back as if the transaction never ran. A failed transaction is still recorded as having been attempted, and the ether spent on gas for the execution is deducted from the originating account, but it otherwise has no other effects on contract or account state.
Sir,
So, yeah,
so can you go to the previous slides?
yeah. Still previous?
Sir, it has not changed, I guess. Okay, one more.
Okay. Transaction rules.
No, sir. One more. Yes, sir. Sir, you wrote this. The Ethereum address of contract can be used in transaction as a recipient,
Yeah,
sending
you can
funds to
receive
the
it.
contract.
You can use that particular address, right, to receive something as a recipient, and
Sir,
also sending funds to the contract or calling one of the contract's functions. Three things you can do.
sir, in the previous rules of previous setup, right? What we did is we made a smart contract using Solidity IDE, and then we deployed it to two nodes.
Yes.
So, does it mean that whenever some user join this network using EOA
Huh?
account, you
Hmm.
said that previously that there are two kinds of accounts, EOA and one is smart
Contract.
contract.
Huh.
So when someone joined this network using EOA account
So
type,
it is controlled by the user himself. EOA is controlled by the user himself, and contract accounts are actually controlled by the smart contracts.
so what does it mean that deploying this smart contract on particular node? Does it mean whenever someone wants to uh, do something, and when some event triggers, then this node will run smart contract on behalf of them? Is it the meaning?
The exact meaning, as you say, uh, there has to be a triggering event or there has to be a transaction which needs the intervention of a particular smart contract. So that particular smart contract contains the respective type of code meant to perform a particular type of an action. So
But
what you are saying is correct. Be a triggering event, and that particular such has called a smart contract, and on behalf of that particular node, that particular smart contract is now getting executed, and having getting executed, it will return the particular type of result to that particular node. Yes.
so for example, you are having one node where smart contract has been deployed, and
Okay.
I'm making some transaction, and result of this transaction, as a result of this transaction, an event triggered,
Correct.
which in turn calls the smart contract, which requires intervention of smart contract, right?
Correct.
So
Correct.
your node where I have deployed, where the smart contract is been deployed, that node will computation on behalf of my transaction. Is it so?
Yes, it has to be like that.
And then I have to, matlab, this node, the my node has to pay some money to you, some funds to you, because your node has done some computation on behalf of my transaction.
Yes,
Is
because
it
it is
so?
controlled, because this particular smart contract is controlled by the smart contract only. Right. So you have to pay. Yes, that's right.
Sir, so I didn't understand where this, what does it mean? I don't understand what is this Ethereum address of contract using which we can send some funds.
See,
Because
particularly what happens is the transfer of assets, transfer of funds, right? So transfer of funds may be in the banking or the financial sector. So ये जो say for example मैंने आपको कुछ पैसे भेजे, पर ये जो पैसे मैंने आपको भेजे, that must find a record somewhere. So this particular record somewhere is the is on the network, right? So ये जो कोई भी लेन देन हम दोनों के बीच में हुई, that particular thing has to be noted, recorded somewhere. The transaction needs to be recorded somewhere, which may be done by a particular type of a smart contract. So say for example, if you purchase something from me and you have to pay to me, then this is what your smart contract is particularly doing.
but sir, how would I identify that which of the nodes have we among which nodes, uh, sorry,
नहीं, इधर तो
how would
इधर तो मैडम दो ही
sir,
नोट्स है ना, मेरा और आपका ही है
sir,
ना.
यहाँ पे दो नोड है, but supposingly when we have multiple nodes, more than 2 3 nodes, and
Okay.
say for example, we have 5 nodes. Out of these
Okay.
5 nodes, on 3 nodes, the smart contract has been deployed. So
Barabar.
these 3 nodes can run the smart contract.
Correct.
Okay, based on some event. Now,
Okay.
suppose I am making a transaction, which in turn has triggered this smart contract. So any
तीनों
of this,
तीनों 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 नोड पर स्मार्ट कॉन्ट्रैक्ट उसने ट्रिगर कर दिया है.
matlab the rules written in such manner that the smart contract will start getting executed on all of 3, right?
All of 3. Okay.
Yes. Then to whom I will pay? To all of 3, to one of them, to whom?
नहीं, you have to pay to only one. क्योंकि
Yes.
they have to synchronize. वो तीनों शुरू हो गए. एक्चुअली सेम कोड था उनका, पर उनको इंटरनल सिंक्रोनाइजेशन होगा, और ये इंटरनल सिंक्रोनाइजेशन की वजह से एक ही पर्टिकुलर नोड होगा जिसको आपको पे करना पड़ेगा. तीनों को तो नहीं, नॉट एट ऑल.
So, sir, what kind of synchronization is required? Will they
वंस
agree on?
अगेन ये जो आपका स्मार्ट कॉन्ट्रैक्ट भले 3 नोड्स पर था, पर ये 3 नोड्स पर वो एग्जीक्यूट नहीं होगा, एक ही नोड पर वो एग्जीक्यूट होगा.
So, sir, how they internally decide that, okay, on your node, you should run this smart contract. This time I should run. Who will decide that? How they, is there any protocol
इसमें
for that?
इसमें 3 प्रकार की चीजें होती हैं. एक जिसको अपन कह सकते हैं रेस कंडीशन, मतलब तीनों लग गए काम में, बट तीनों लग गए काम में उसकी जरूरत ही नहीं थी एक्चुअली, क्योंकि तीनों के पास वो स्मार्ट कॉन्ट्रैक्ट का कोड था, right? So there is a particular type of a synchronization mechanism which will take into account, and only one node needs to execute that particular smart contract, and that particular code needs to be once again written in the smart contract. क्योंकि अगर मल्टीपल नोड्स पर आप कह रहे हो कि ये स्मार्ट कॉन्ट्रैक्ट एग्जीक्यूट हो रहा है, तो दैट शुड नॉट बी पॉसिबल एज सच. ये होना नहीं चाहिए.
Okay. And sir, contract is one transaction, right?
Okay.
Contract
Yeah.
is itself a transaction.
Contract is itself a transaction. Okay.
So, and we know that every transaction will be having an Ethereum address.
Okay.
So, sir, irrespective of on how many nodes I have deployed that smart contract,
Address will be different.
sir, but transaction is same. The contract
भले
is
ना
same.
हो, भले ना हो, पर address will be different, no?
Uh, sir, but transaction is only one, right? The
Yeah,
smart
you are
contract
correct. You are correct, but particularly addresses will be different. So वो
So
नक्की कर
address
लेगा.
is not associated with smart contract transaction. It is associated with a node on which it has been deployed.
देखो क्या हुआ, फिर से क्या हुआ, ये स्मार्ट कॉन्ट्रैक्ट तो 3 नोड पर आपने किया हुआ है, तो अगर मैंने एड्रेस स्मार्ट कॉन्ट्रैक्ट के साथ डाल दिया होता तो ये तीनों एग्जीक्यूट होने ही वाले हैं, कुछ भी कर लो आप, फिर तो होना ही है. और उसके साथ नहीं है, राइट? वो नोड का एड्रेस के ऊपर है पूरा.
ओके सर.
हाँ, नहीं तो ये तीनों होने ही है, फिर तो देयर इज नो चांस. इसलिए इट हैज टू बी एसोसिएटेड विद द नोड एड्रेस ओनली.
ओके सर.
So that only one can do the particular type of thing.
Okay, sir.
Okay, so smart contracts are automatically executable programs. A smart contract is a software script that describes the relationship of users. In fact, it is similar to the usual legal contracts that we are used to seeing, only with some differences. The algorithm of smart contract is stored in the blockchain and starts actions under certain if-then conditions. To make it more clear, consider a few examples. If the user invests 10 ETH in the system, 10 one, if the user invests 10 ETH in the system before January 1, then he receives 1000 tokens plus 10%. If before January 30, the balance in the system will be less than 100 ETH, all users will receive a refund. So there are some if-then type of rules written. So as you can see, the main benefit of smart contracts is the absence of intermediaries. Everything is controlled using a pre-written program or a script. The most popular solution is the use of the Ethereum platform. In order to use a smart contract, you need to create a wallet and start the transaction. Sign up in Ethereum.org, download the crypto wallet from the Ethereum wallet tab and install it. Create a signature and come up with a private key. Go to the section for creating transactions. Here you can specify the crypto wallet data, the transfer amount, and add the program code in the input field. It is here that you can insert a script of a smart contract or use a ready-made template. Then let's talk about decentralized applications or DApps. A decentralized app, yeah.
Sir, can you please explain the previous slide?
Okay, yeah. The most popular solution, this one.
Yes, sir.
So the what we were actually talking was about what is a smart contract. So we said that a smart contract is a software script. Everything is written in
So
the
this I
software
got.
script. So
This
without
I
any
got.
intermediary, you are able to control everything which is to be executed by the software script. Okay. Now the most popular solution is the use of the Ethereum. So smart contract का आपको अगर solution चाहिए तो आप use कीजिए Ethereum platform का. So in order to use a smart contract, you need to create a wallet and start the transaction. So you can sign up in Ethereum.org, download the crypto wallet from the Ethereum wallet tab and install it. Create a signature and come up with a private key. Go to the section for creating transactions. Here you can specify the crypto wallet data, the transfer amount, and add the program code in the input field. It is here that you can insert a script. I will be actually doing it in further slides.
Okay,
Some transfer of money I will be doing.
Demo kind of thing.
Can insert a script of a smart contract or use a ready-made template. I'll do this particularly in one of the further slides as such. मैं करता हूँ इसको, आपको समझ में आ जाएगा ये.
जी sir. Okay.
So a decentralized app is an app where the server side is just one or more well-known smart contracts that exist on the Ethereum network. Server side is just one or more well-known smart contracts that exist on the Ethereum network. These distributed applications are usually accompanied by some sort of user-friendly front end. A DApp client is any client of front end, as you would normally use the term in programming, except that this client interfaces with the Ethereum blockchain, perhaps in addition to other services somehow. These clients are frequently written in JavaScript because we have not yet finished converting everything in the world to Node.js, Node.js, AngularJS, right? So इस तरह की चीजों में conversion आज की तारीख में चल रहा है सारे सॉफ्टवेयर्स का. So Go and to a certain extent Rust are also used as options. A decentralized app does not need to store all of its state and perform all of its computation on the blockchain. It stores trusted state on the Ethereum blockchain, which anyone can then read. Many centralized apps also use technologies like IPFS and Golem to handle computation and storage of the Ethereum blockchain, but in an equally decentralized manner. IPFS is a peer-to-peer hypermedia protocol designed to make the web faster, safer, and more open. Golem, global open source, decentralized, that anyone can access. It is made up of combined power of user machines from PC to entire data centers. Solidity is a contract-oriented, high-level programming language for implementing smart contracts. It is highly influenced by C++, Python, and JavaScript, and has been designed to target the Ethereum virtual machine. Solidity is statically typed, supports inheritance, libraries, and complex user-defined types programming language. You can use Solidity to create contracts for usage such as voting, crowdfunding, blind auctions, and multi-signature wallets. Ethereum design philosophy is number one, simplicity. The Ethereum protocol should be as simple as possible, even at the cost of some data storage inefficiency or time inefficiency. An average programmer should ideally be able to follow and implement the entire specification. Universality. Ethereum does not have features. Ethereum provides an internal Turing complete scripting language which you can use to construct any smart contract or transaction type that can be mathematically defined. Invent your own financial derivative. Make your own currency. Set up a full-scale daemon or Skynet. You may need to have a few thousand interblocking contracts and be sure to feed them generously to do that, but nothing is stopping you. Then modularity is another feature. Different parts of the Ethereum protocol should be designed to be as modular and separable as possible. Over the course of development, it should be easy to make a small protocol modification in one place and have the application stack continue to function without any further modification. Innovations such as Dagger, Patricia trees, and RLP should be implemented as separate libraries and made to be feature complete, even if Ethereum does not require certain features so as to make them usable in other protocols as well.
Sir,
Ethereum developed, yeah,
sir, what is this dagger and patricia
they are
trees?
the tools. They are the tools. They are the innovations. They are the tools which have been developed for Ethereum. Dagger, Patricia trees, and RLP. They should be implemented as separate libraries and made to be feature complete, even if Ethereum does not require certain features so as to make them usable in other protocols as well. Right? So
So
ये सारी
dagger is
चीजें
meant for what?
Dagger is meant ये feature देने के लिए. See, when we go to the last slide, इसमें क्या बोला इसने कि Ethereum does not have features.
Sir, so
Ethereum does
dagger
not have.
provides which kind of feature?
हाँ,
Every
Ethereum
library is been built for providing a particular feature. So
Ethereum does not provide any features, and that's the reason why it is able to run on any of the platform. And such type of features, if you want to be provided in Ethereum, then you can use the innovations such as Dagger or Patricia trees and RLP. These are the features. ये features आप provide करने के लिए use कर सकते हो, right? And need to be feature complete, even if Ethereum does not require certain features so as to make them usable in other protocols as well, right? Other than Ethereum protocol.
okay, sir.
So Ethereum development should be maximally done so as to benefit the entire cryptocurrency ecosystem and not just itself. Then non-discrimination, the protocol should not attempt to actively restrict or prevent specific categories of usage. and all regulatory mechanisms, government imposed mechanisms in the protocol should be designed to directly regulate the harm, not attempt to oppose specific undesirable applications. You can even run an infinite loop script on top of Ethereum for as long as you are willing to keep paying the per computational step transaction fee for it. If you are revealing, you can run that. Then agility, a very important feature in today's features. So details of the Ethereum protocol are not set in stone. They are agile, although we will be extremely judicious about making modifications to high-level constructs such as the C-like language and the address system. Computational tests later on in the development process may lead us to discover that certain modifications to the algorithm or scripting language will substantially improve scalability or security. Sorry. So Solidity basics में कहता है it's an object-oriented high-level language for developing dApps on the Ethereum blockchain. Solidity's code is encapsulated in contracts. A contract in the sense of Solidity is a collection of code, its functions and data, its state that resides at a specific address on the Ethereum blockchain. Ethereum blockchain allows us to execute code with the Ethereum virtual machine on the blockchain with a smart contract. Smart contracts are where all the business logic of our application lives. All variables and functions belong to a contract, and this will be the starting point of all your projects. Contracts are in the program of ECS, that is JavaScript and C. It compiles to EVM bytecode through its compiler known as SOLC. EVM, that is Ethereum Virtual Machine Bytecode. Remix is an online tool that allows you to write Solidity smart contracts, then deploy them and run them. You can go to https://remix.ethereum.org from your browser and we can start coding. So this is what is the Remix IDE screen, integrated development environment. So you have two environments here, Solidity and Viper. Featured plugins में pipeline वगैरह वगैरह दिए हैं. Then you have the Remix UI. In the user interface, you can choose between Solidity and Viper. Both are languages for writing smart contracts. Viper is Python-like and Solidity is JavaScript-like. Both can compile to the EVM bytecode, kind of like JavaScript and TypeScript. Start choosing Solidity for writing our smart contracts. So on the left-hand side File Explorer window, there are .sol files. Just to demo basic syntax, ballet.sol is smart contract. ballet_test.sol is script for testing that smart contract. Select create new file and give the file name. Then version compatibility is important and the methodology you should understand. All Solidity source code should start with a version pragma, a declaration of the version of the Solidity compiler this code should use. This is to prevent issues with future compiler versions, changes that would break your code. Pragma Solidity version 0.4.25 for the Solidity version above 0.4.25. Pragma Solidity greater than or equal to 0.5.0 less than 0.6.0 for the Solidity version between 0.5.0 and 0.6.0.
Sir,
So yeah,
There is one request from participant
हाँ
that
बोलिए.
it would be better if you show some private transaction using Ethereum wallet so we can clear our concept.
बेटा अभी पॉसिबल नहीं है ये मेरे सिस्टम पर. मेरे को
Okay.
पूरी चीजें मेरे पास है नहीं अभी ये सब सॉफ्टवेयर.
Sir, is there any virtual machine or platform where the entire or demo Ethereum network is installed? We just show, you can showcase that part only.
नहीं नहीं वही नहीं है मेरे पास अभी, वो इंफ्रास्ट्रक्चर नहीं है मेरे पास. But anyway, later on, I'm trying to develop some certain things for that, and I will be sharing with you also. Right? So, but abhi possible nahi ho payega ye because I don't have that particular infrastructure.
Okay, sir.
Eh? But future, mein definitely I'll do it with you. That is my
Okay, sir.
promise. That is my
Okay, sir.
promise.
Okay.
So create your contract by typing the reserve word contract and the name of your .sol file after the pragma statement. It is important that contract name matches the name of the file. So version, pragma solidity, so and so, contract name, function. First use the reserve word function, then the name of the particular function, and parameters after that, that is the visibility specifiers. So function, my function bracket returns bool, yes or no, brace return true. Functions can either be public or private. If a function is public, it can be called outside of contract. And if a function is private, it has a limited scope and can be called from only from its current contract from some other function, for example. Visibility specifiers का public है, private, external, internal. So public, visible externally and internally, creates a getter function for storage state variables. Private, only visible in the current contract. External, only visible externally, only for functions, that is, can only be message called via this dot func. Internal, only visible internally. Functions can be pure, view, or payable. If a function does not write any data on the blockchain, it is very much recommended to be a view because view functions do not cost any gas. Function modifiers for state variables, events, and event arguments. So pure disallows modification or excess of state. View disallows modification of state. Payable allows them to receive ether together with a call. If function returns some value, you need to specify that with reserved word returns and then in regular brackets to specify which type this function returns. In our case, it will be a string because we return our variable messages, which is a string. If the function does not return any value, there is no need for the returns statement. Then state variable. To access a state variable, you do not need the prefix this, as is common in other languages. Because of that, a common practice is to write function arguments with underscore syntax, underscore message. This convention came from JavaScript, where private methods and variables always start with underscore. To be clear, your code will work fine with and without underscores, but it's cleaner with them. In memory, if you write your code without memory and set pragma to some version under 0.5 it will work just fine. But when you change your compiler to above 0.5 EVM generates compile error. And why does this happen? The Ethereum virtual machine has three areas where it can store items. The first is storage, where all the contract state variables reside. Every contract has its own storage and it is persisted. It remains between various function calls and it is quite expensive to use. The second is memory. This is used to hold temporary values, it is erased between external function calls and is cheaper to use. The third one is the stack, which is used to hold small local variables. It is almost free to use, but can only hold a limited amount of values. For almost all types, you cannot specify where they should be stored because they are copied every time they are used. But when you work with arrays or structures, and from latest versions with strings also, compiler will force you to specify the store area, whether it is the stack, whether it is the memory, or whether it is the storage. So function code, function get bracket public return string memory return message, function get bracket public view return string return message, function get bracket public view return string return message, and function set, of course, string memory underscore message public message equal to underscore message. That's what exactly is the syntax. So you have this particular amit.sol file. So create, compile, deploy, and run transaction. Pragma solidity version so and so, contract amit, string message, function get bracket public view return string memory return message. Set भी है, function set. Then the constructor. So the message that we have defined here is hello world. Then visibility of state variable. The concerns for the visibility of state variables are, if you make your state variables all public, that means that one can claim their values from outside the contract. Solidity will make for each public state variable a method with same name which can be called as a regular function like getter function. Our code will work in the same way. It will be much cleaner and it will cost us less to deploy it one day to the main network. The bigger the code, the more gas is needed to execute it and the cost of running our DApp increases. When we develop smart contracts, we need to be efficient. The gas rate consumed needs to be low. We need to be precise. Once you deploy smart contract, it cannot be changed and it is public 24/7 hours. Every single line of code. Imagine a hacker who finds a bug and can exploit your DApp. Right, so OP code, consider the following simple smart contract, Pragma Solidity version so and so contract example, UINT of A equal to 10 plus 5. The bytecode generated for above smart code is as under. That's the bytecode generated. So the basic explanation of the OP code is push 1 0x60 means putting a 1 byte value of 0x60 in the stack. Coincidentally, the hexadecimal value for push 1 happens to be 0x60 as well. Removing the non-compulsory 0x, we could write this logic in bytecode as just 6060. Let us go a bit further. Push 1 0x60, push 1 0x40, M store. The M store 0x52 address takes in 2 inputs and produces no output. The OP codes above mean push 1 0x60, put 0x60 in the stack, push 1 0x40, put 0x40 in the stack, mstore 0x52, allocate 0x60 of memory space and move to the 0x40 position.
Sir,
Yeah.
what is this OP code and where we should write
code? Operation code. So you have a particular type of a contract example where you have uint a equal to 10 plus 5. That is the equation that you have provided. And the bytecode which has been generated for this smart contract is as under. This is the bytecode. And the explanation of this particular bytecode has been provided in the next slide. So if you observe, it is 0x60, 8060, 4052, and so on. So 0x60 is the start address. 0x60. So ये थोड़ा लोअर लेवल का कॉन्सेप्ट है, असेंबली लेवल का. Sorry. So बात का था 6060604052, right? So in fact, we always see this magic number in the beginning of any Solidity bytecode because it is how the smart contract bootstraps. To further complicate the matter, 0x40 or 0x60 cannot be interpreted as the real number 40 or 60 since they are hexadecimal. 40 actually equates to 64, that is 16 raised to 1 into 4. And 60 equates to 96, that is 16 raised to 1 into 6 in decimal. In short, what push 1 0x60, push 1 0x40 mstore is doing is allocating 96 bytes of memory and moving the pointer to the beginning of the 64th byte. We now have 64 bytes for scratch space and 32 bytes for temporary memory storage, totaling to 96 bytes. In the EVM, there are 3 places to store data, as we saw. Firstly, in the stack, we have just used the push OP code to store data there as per the example above. Secondly, in the memory, that is random access memory, where we use the mstore OP code. And lastly, in the disk storage, where we use ssstore to store the data. The gas required to store data to storage is the most expensive, and storing data to the stack is the cheapest. So that has the relationship. ये relationship है OP code का. I think that makes sense, or no?
Sir, we are not supposed to do all these things. These are
अच्छा,
low level concepts, right?
हाँ, थोड़े low level concepts है.
Okay.
Okay, चलो token. Token तो अपन suppose है ना?
Okay, sir.
So tokens are essentially smart contracts which live on the Ethereum blockchain. They can have many uses and purposes. A token is not limited to one particular role. It can fulfill a lot of roles in its native ecosystem. Here is the list of some roles that tokens can take. The first role that it takes is toll. A token can act as a gateway to a DApp. Basically, in order to access the DApp, you will need to hold the tokens.
So what does this mean?
It means जैसे 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 आपको एक्सप्रेस हाईवे पर पर्टिकुलरली टोल देना पड़ता है उस हाईवे को यूज करने के लिए, इसी प्रकार से अगर आपको कोई डिसेंट्रलाइज्ड एप्लीकेशन एक्सेस करनी हो तो यू विल नीड टू होल्ड द टोकन्स so that you are able to pay those tokens as toll. So a token can act as a gateway to a DApp.
So
Basically,
I need to deploy this toll token on my machine.
Yes. In order to access the DApp.
Sonia ma'am, do you have any question? Hello, ma'am, are you there? Okay, sir, you can continue.
Okay.
So these are predefined smart contracts.
Yes. 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 Then voting rights. The tokens may also qualify the holders to have certain voting rights. अगर आपके पास टोकन है तो आपके पास voting rights भी होते हैं. Think of EOS. Holding EOS tokens will allow you to vote for block producers. EOS blockchain is aiming to become a decentralized operating system which can support industrial scale decentralized applications. Then value exchange. This is one of the more common roles of tokens within the ecosystem. Tokens can help create an internal economic system within the application. User experience UX enhancement. The token can also enable the holders to enrich the user experience inside the confines of the particular environment. For example, in Brave, a web browser, holders of BAT tokens such used in Brave will get the rights to enrich customer experience by using their tokens to add advertisements or other attention-based services on the Brave platform. Currency can be used as a value, which can be used to conduct transactions both inside and outside the given ecosystem.
Sir, can you explain this voting rights and value exchange?
Correct. See, basically what happens is that we are talking about the concept of tokens. So tokens can help you, number one, for toll, right? So you can get an access to your D app by using these tokens. Number two, if you are holding these tokens, then you have certain voting rights, right? So ये पूरा जो blockchain है, right? उसमें अगर कभी वोटिंग लिया जाए तो आपको, क्योंकि आपके पास टोकन है, इसलिए आपको वोटिंग राइट मिलता है, राइट? सो ये जो इंडस्ट्रियल स्केल डिसेंट्रलाइज्ड एप्लीकेशंस होती हैं, राइट? सो यूएस ब्लॉकचेन इज एमिंग टू बिकम अ डिसेंट्रलाइज्ड ऑपरेटिंग सिस्टम व्हिच कैन सपोर्ट इंडस्ट्रियल स्केल डिसेंट्रलाइज्ड एप्लीकेशंस. देन वैल्यू एक्सचेंज, मतलब अगर आपके पास टोकन है तो कितने का टोकन है आपके पास, अगर आप चाहो तो उसको किसी और वैल्यू में कन्वर्ट कर सकते हो, राइट? सो टोकन्स कैन हेल्प क्रिएट एन इंटरनल इकोनॉमिक सिस्टम विद इन द एप्लीकेशन. आप किसी शॉपकीपर के पास जाते हो एंड मे बी उसके पास से फॉर एग्जांपल चेंज नहीं है, तो वो अपने हाथ से एक टोकन लिख के दे देता है कि ओके, नेक्स्ट टाइम यू come for purchasing some item from me, this much I will deduct from your account, right? So that is what is called value exchange. So एक internal value exchange बनता है. Then इसी तरह से user experience का enhancement कर सकते हो आप. So one example that I have taken here is of a web browser called Brave, and उसमें ये जो token है उसका नाम है BAT. It can give the rights to enrich the customer experience by using tokens to add what? To add advertisements or other attention-based services on the Brave platform. And then as a current, you can use it if you have tokens. It can be used as a store of value, which can be used to conduct transactions both inside and outside the given ecosystem. Am I clear or no?
Okay, sir.
Okay. So next slide is Ethereum smart contracts. So 3:30 बज रहा है. Can we have a half-hour break? 4 o'clock we'll start with this.
Yes, sir. We can meet
Okay.
at 4 p.m.
हाँ,
Okay.
आप भी चाय कॉफी ले लीजिए, मैं भी चाय बात पी लेता हूँ. And 4 o'clock we meet. Okay.
Okay, sir.
Okay. Thank you very much.
Okay. To all the participants, we'll meet at 4 p.m. and join using the same link. Thank you.
Okay. Thank you.